Hey everyone, this is Ampro Engineering, and this is finally going to happen. I have been avoiding this just because I know it's going to be a lot of work, but the Willy's wheeler is going to get some lights. I've been asked by many people how I do this, and I was kind of trying not to make a video on this because, I don't know, maybe the way I do it isn't like how some kind of electrical engineer does it, but it does work. You know, I've had many cars with this lighting system that I'm going to install for years and years and years, and everything seems to work great. Well, before we begin, we need to try and figure out our direction. For this particular project, since the turn signals, the tail lights, brake lights, reverse lights are all going to be controlled by the lighting unit, all I need to deal with here are the headlights, the fog lights, and the side markers. And as I mentioned, I'm going to have these so that they're on constantly, just because I'd prefer that. For me, soldering requires a frame of mind. So I find it to be, I kind of find it a little bit tedious. I don't love doing it, but overall, it's not that bad. So you need to kind of prepare yourself mentally, physically, and emotionally. That said, I've got my soldering iron way in the back right there, all ready to go. I have my bag of resistors, which we're gonna use here. I have my bag of LEDs here. This is overspray from a project, in case you're wondering why my thumb is blue. And then I have my resistor color code chart, which I think I got in freshman year of high school, so this guy's been around a while. I also need to figure out what our resistor values are going to be for the receiver. In order to do that, we need to understand what the voltage that your receiver is outputting. So let's go ahead and grab the receiver and test the voltage. So what I want to do here is very carefully measure what the voltage on the receiver is. And let me try and make it so that you can see what's actually going on here. Looking at the receiver, we can see what the voltage is using the diagram that's shown right here. So this means that it's negative, positive, and signal. Negative, positive, signal. So what we want to do is very carefully touch the negative to the negative and the positive to the positive. And be careful here, you don't want to short anything out. So positive to positive, negative to negative, 5.7. The voltage that we recorded was 5.6 volts. Normally you're looking at a 5 volt system, but I found with the higher voltage batteries that the speed control, especially the older ones, are going to pump out a little bit more voltage. I don't know if that's just me or if that's kind of happening more commonly. So I like to err on the side of a little better or a little larger of a resistor, because this will prevent the LEDs from burning out too early. So I like to go to this website here. It's called led.linear1.org. Initially, when you log in, you're going to have this LED calculator for a single resistor. So here you put in the source voltage, and forward current. Well, we want more than one, so I'm going to go ahead and click on the LED series parallel array wizard. And now we're on this page here. So for source voltage, I'm going to type in 5.6. Now for diode forward voltage, you'll normally have to check the package that your LEDs came with. In this case here, there's a little Q&A area here, and we can see that there's some pretty standard voltages here. We'll start with white, and that appears to be 3.3 volts. So diode forward voltage, 3.3, and this is each. Okay, so there's, put that in once. As for forward current, normally diodes seem to be around 20 milliamps. So again, 20 milliamps. You can see here that it's currently in milliamps. For number of LEDs, and I did mention we wanted 6, but I need 2 white ones. So we'll type in 2. All right. And come over here, and we can see that with 5.6 volts, we need each LED to have its own resistor. That's what that means. So here's our power source coming into the positive side of the resistor, the diode. From the negative side, it grabs the resistor and then it goes to ground. That's what that's talking about there. We need these 220 ohm resistors. So if you don't know how to figure that out, we've got my little chart here. So we need 120. So first digit is 1, second digit is 2 for 12, well 1, 2, and then the multiplier is 12 times what would make it 120, which is 10. So we're looking for brown, red, brown. Now there is a fourth stripe here, well fifth if you've got 3 digits, but there's normally a fourth, which is going to be the tolerance of the resistance of the resistor, which is normally the silver or the gold down here. You do have some additional ones over here, brown and red as well. These are a little less important for what we're working with. So right now we're looking for brown, red, brown. Now I'm pretty paranoid about the resistor because honestly, if you haven't dealt with these very much, these colors are so tiny. It's like, is that brown or is tan an option? What about taupe? So I don't know, this is always kind of annoying for me. So I do a couple of things. Number one, I have this awesome app called Resistor Vision. So you basically aim over here and it'll show you it's 120 ohms. Awesome. Again, I don't entirely trust everything. So we're going to go to resistance here, press this to this. Is that resistance? All right. So we are 115.5. Okay, 115.5. The last band on this is gold. Gold means a 5% deviation. So that would mean that if it was 100 ohms, it would be allowed to be 5 ohms off. In this case here, it's 120. It's still 5 ohms off, so we are good as gold. All right, so we have our resistors. Now we need our diodes. When I wire my LEDs, I like to put them in place so I can determine how long the wires are. But also, this is a good place to just let them get held and, kind of get held because it's going to be retained by the bucket. I need to wire the resistor onto the negative side. Now, the negative side is called the cathode. The cathode is determined here by the length. So you can see that the shorter one is the cathode, the longer one is the anode. The problem is if these get snipped, now you can't tell using the wire length. So looking at the LED, if you do not have the both of these legs still intact, you can tell its voltage because the top of this portion of the LED is rounded. The lower portion of the LED, I'm going to try and get it with the light reflecting off, has a flat. That flat side is the negative side. Okay, so if your anode and cathode legs have been damaged or cut, you can still tell what is negative and what is positive on the LED. It's very important that you use a high quality soldering iron. I've got a 30-watt unit here by Ungar, and the lower current ones may take a little bit longer to melt the solder, and this could ultimately result in too much heat being transferred to the lead here and potentially destroy or damage the LED. So I'm going to take some solder. God, this is so hard with the camera in my face here. All right. If I screw this up, it's your fault, just FYI. I'm going to take a little bit of solder and just kind of tin this wire just a bit, and we're done, okay? Same with the other side. Put a little bit of solder on it. This way, when we attach the resistor, it already has some solder on there to bind. I'm going to do the same thing to the resistor. Same thing here, just put a little... Why isn't that working? There we go. A little dab of solder. And now that we've done that, it'll be much easier to attach the resistor to the LED. I did mention earlier that the cathode, the negative side of the LED, is going to be on the upper portion here on mine. So I will take a little bit of solder, put it on the iron, and connect. God, this is such a pain. Oh my God. There we go. This is a nightmare like this. Okay, they are connected. You're probably thinking to yourself, these two leads, the anode and the cathode, are far too close to each other, and when they touch, they'll short out. And you would normally be correct if I wasn't going to do something a little bit interesting a little later on. So we will get to that and address it. I'm going to go ahead and do add the resistor to the other side now. The white headlights have been placed into their buckets, and over here I've also got a couple other LEDs. These are ultra bright yellow 3mm LEDs. These are going to go into the fog lights. And here we have some amber diffused LEDs. The reason why I got these diffused ones is these are going to go into the side marker. And it just looks kind of, I don't know, super bright if you put a super bright amber LED. Does it really make much of a difference? I don't know, we'll see. I just want it to be a little more realistic, so I just picked these up over here. So much like before, we're going to put their information into the LED calculator, but we are using these amber and yellow LEDs, so there's a little option here that goes diode forward voltage. I'm going to click on that real quick. So here we can see that orange is 2 and yellow is 2.1. Now this is going to be very important because, like with the white ones, I have to accurately put in the forward voltage. In this case here, we'll put in 2 volts. They're all going to be 20 milliamps. There's only going to be 2 there as well, 2 quantity. We'll hit design my array. And here we're going to see that we need an 82 ohm resistor. Now it's showing this in series. I don't know if, I really don't know if I like that. The problem with doing these in series is the second one, at least in my experience, I've always found that the second one's always dimmer than the first. So I'm probably going to come back over here and say, all right, you know what? I'm going to do these things well, I'm going to say in parallel, but the way this works is, as with the white ones, when those were 3 volts, 2, okay. So these are wired in parallel. Basically, this means that this is one complete circuit, and this is a second complete circuit. So I don't want to deal with that weird series things. Again, I've had bad luck with it in this case, so I'm just going to do 2 of those 180 ohm resistors in line with each amber LED. Okay, so I'm going to go ahead and place these in. I'm going to pull up some of these resistors and move forward. I have all the LEDs in with their respective resistors. You do want to test these because you never know if you've wired something backwards, and it's always unfortunate to get the whole thing put together and find out it doesn't work. And what I've done here is I just have a little receiver pack. It's 4.8 volts, close enough to what we're to our desired voltage. This wire here is one of the legs from the resistor, and I've plugged in the resistor that I soldered on into the negative terminal. And I'm just going to touch these together, and you can see that it is in fact operational. When I was testing them all, I did discover that one of the blue LEDs got mixed in with the whites. So fortunately, I was able to pull that out and replace it before I was annoyed at a later date. Next, what I want to do is prevent these wires from touching. Now, there's a couple of options. Option 1 is liquid electric tape. Now, this does a couple of things. Number 1, it prevents any short circuiting of the LED's legs. Secondly, it also covers up the LED from behind to prevent any light bleed. You can also take a piece of shrink wrap and just push it over there and heat shrink it into place. I like to do a little bit of both. In fact, all I'm really concerned about is this little bit of wire here next to the LED's legs are. I don't want those two to touch. So I'm just going to cut a little bit of wire. We'll make it the same length as the leg with the resistor. I think it's good enough right there. Push it right over there. And then I can just take my lighter and let's heat shrink it on. Okay, and there we have it. Is it necessary to do both? No, not really. It really isn't necessary, nor is this very well done. Normally I will use a much shorter leg, but it tends to get a little bit tedious when it comes to some of these areas on the car where there's a lot of bending. What I mean is the LED is placed in an area that's very close to the front bumper of the car as well as the front tire. So I bend these legs almost 90 degrees to make sure that nothing gets in the way. With a little more leg here, I can actually bend it in the center like so. So it's a little better to bend over here than it is to bend at the LED, because later if you make a mistake, you can bend it straight back very easily. If you bend it at the LED, it's possible it'll break the lead. Okay, so make sure you test all your LEDs. I'm going to put some of these shrink wrap tubes over some of the resistors, and then we're going to wire them all together. It is time to wire. I'm going to use this ribbon cable because for me, this really reduces the amount of wiring, or I should actually say just clutter in the car. And since this is a 6-wire ribbon cable, what I'm going to do is split it into 2s. Now, I'm actually going to keep it as attached as I possibly can. These are really a great source of wires, especially if you've got old hard drives or something like that, old computers. The wire gauge is very, very small. It's a very low current draw product, so these work really nice. You can just peel them all off and have 6 nice high gauge wire, and this is going to be awesome to wire these up. So I'm going to wire this one here to the positive and this one here to the negative. I'm going to wire again all the other resistors in the same fashion, and then at the last step I'm going to wire all the positives and all the negatives together to a single plug. This way that one plug will be controlled by a single switch and they'll all come on or all shut off at the same time. Now, you don't have to do this. You can have multiple plugs to multiple switches if you want to have like the fog lights on sometimes, the fog lights off sometimes, and etc. I'm going to tin these wires and then we'll solder them to one of the LEDs just to show you how it's done. And I will then let you use your imagination to see how I did it to the other 6, because soldering on the video camera is absolutely the worst thing in the world. Let me tin these and I'll be right back. Wires have been tinned and now we are going to begin the wiring process. And what I've done is I've kind of backed the wiring with this very flammable piece of paper. So hey, that could be fun. 1 million views, here we go. So I have staggered the wire lengths for a couple of reasons. Number one, oh my God, that's not going to work, is it? Oh man, there we go. All right, the first reason why I've done that is so that the wires, when they are actually soldered together, there we go. There you go. So I've done this, stagger these wires so that when they are in fact soldered together, they're a little bit tidier. Secondly, it also prevents them from shorting out. And as I mentioned, we are going to later cover everything in liquid electric tape, and that is primarily a lighting issue that we're going to try and resolve there. So let's go ahead and do that again. Sorry, this is about the hardest thing you can do here, solder on camera. There we go. The next thing we're going to do, and I've soldered them in the car simply because it's a really great way to hold the LED in place. All right. Now, on the Willy's Wheeler, the bumper, as I recall, goes right here. Okay. So what we want to do is make sure that the LED does not pass in this area, because on the Wheeler, especially with these little grills that I made, it comes very, very close to these, and I don't want to press the wires up against it. So at this point here, I'm going to take my pliers, hold the base of the LED, and bend the wires back. And again, the reason why I'm doing it like that is so that they don't, break at the bottom of the LED. And now we'll be able to route the wiring in this valley right here. And I'll tidy it up a little bit more off camera, but you get the basic premise here. The wire is going to flop around, which is why we have our trusty friend, the hot glue gun. We're going to hot glue the heck out of this thing and make sure nothing budges. Well, I went ahead and wired everything together, and again, there are 6 wires here. Every other one was positive, every other one was negative. I simply wired them all together. And what I did is I just wired them all into a positive and negative lead that goes to this switch. This wire that's kind of going off to nowhere, this is just if I want to add something later on. I don't have to splice into anything. So this is looking kind of messy right now because these are the turn signals. So now that everything's wired up, we do have our headlights plumb, our fog lights plumb, our side markers plumb, and everything is ready to test out. The first thing I want to do here is, now since I did test everything ahead of time, we did check the voltage going to all of the LEDs ahead of time. I'm pretty certain everything's going to work. because I have this little port here, I can plug these in. I'll try and, here we go, let's shut the light off here. I'll try and plug all of them in, and there we go. Okay, all the lights are on. What I want to do next is wire up some turn signals and brake lights. I'm going to go ahead and put in the last wires for the control unit. I've routed the turn signals are in, so there's my left signal, my right signal, and in this setup here with this brand over here, or whatever, no name. This is called common sense. See, this one here says common sense. This one here says nothing. Interesting. Okay. Anyway, it has a single plug here, and then from here it actually branches off. You can see that right there, and it goes to the front and it goes to the rear. Doesn't matter which one of these goes to the front or the rear because they're going to flash at the same rate. I've got my red lights here, so that's going to go here. And what I want to do first is just see what we're talking about wiring wise. If a nice tidy underbody is what you're all about, you're going to have your work cut out for you because this just gets ugly. All right, here's my reverse lights. And what I'm really hoping is I can put this like right around here. And I don't know. Ooh, man. I don't think I can do that. I don't think that's going to work. It's going to have to go maybe here. Ugh, it's just all so messy. I'm going to try and find a good place for this, and I'll come right back. After a little bit of patience, the body's looking a little bit better. Again, it is kind of busy, I suppose. And the wheeler happens to be a bit tougher of a subject because of all the glass. Now, I have a plan to address that later on, but for the time being, it's a little busy. A good idea is, let's say you just wanted to leave the windows open. It might not be a bad idea to maybe just cover the control module up and maybe paint everything in here that you see a matte black color. This would help to hide it. So that could be kind of an option. What I did back here is I routed all of the plugs to the receiver near where I happen to have placed the receiver on this car. So the next thing I want to do is plug all of these into the receiver, put the body on, and take a look. Before I do that, I do want to make sure that like the front and all of the liquid electric tape I put on these, I also want to cover the taillights because this is going to get really nasty and it's going to have a lot of light coming off of these. So make sure you cover everything up. And I think I have to do the front. Yeah, I have to do the front turn signals too. So I'm going to cover those up first, and then we'll plug in the control unit. So I've got everything all wired up, and now we want to plug in the control unit to the receiver. So I marked the first channel with this little silver mark here. So I'm going to unplug channel 1. Okay, let's get you out of there, buddy. All right, now this is one of those omnidirectional plugs, so make sure that you plug it in the correct way. Let's plug in channel. Oop, that's not channel 1. That is channel 1. Let's plug you in like so. Okay, and then this one here, I also marked with a 1. And just make sure that they are corresponding colors. This is an Airtronics plug, so it has the blue instead of the white. So just make sure that the black and the reds line up. And in this case, they are. The control module is wired up to the receiver now. And before I, put the body back on, I want to go ahead and put a battery in and make sure that everything is working properly. So let's do that next. Battery is in. Let's plug it in here. I'm going to try and just get this out of the way. Radio on. Let's set the, there we go. Okay, Honda City selected. And car is eventually on. Left, right. Probably should unplug the motor. So now the motor's unplugged. And let's see if this works. Oh, good. That's promising. This should be the brake light. Let's accelerate. No, oh wow, it actually gets brighter. This is the standard driving light here. So accelerate, brake. Ooh. Oh shoot, reverse. Check that out. Okay, accelerate, brake, neutral, reverse. Oh, God, that's so awesome. Sorry, that's so awesome. Now I don't know if I plugged the left and the right in correctly, so I'm gonna turn left. Okay, the right's on. Flip that over. Oh, but that looks so cool. Let's go into reverse again. Look at all those lights. Oh man, that's sick. Let me reverse the polarity. Let me reverse the plugs for the signals, and then we'll take a look at the front. I went ahead and switched the sides of the signals. So let's see if the left works properly. Let's turn left. That's so cool. Oh man. Right? Oh, I love that. I could do this for hours. Went ahead and put the body on, and I did test the electrical, and I have to say, it's pretty slick. Let's go ahead and turn the lights on now. Again, I could do this for about 2 hours. Let's take a look at the back. I did plug the motor back in, so... That wraps up this this lighting build. I really hope you enjoyed the video. You know, I'm so used to doing these light kit installations on my cars that I really hope I didn't overlook something that's, you know, second nature to me, but maybe is, you know, a little bit new to you. You know, if I did skip something over, please go ahead and, you know, drop me a message. Love to help you out. Please subscribe. I'm sure I'm going to do way more crazy things like this coming up. In fact, I think my, what's wrong with me? I think my next car is going to be, this is going to be ridiculous. My next full lighting set is probably going to be the Subaru Brat, which I know is going to be nasty because it's got lots of lights and parking lights and driving lights and turn signals and all kinds of craziness. So if you want to see me lose my mind, that would be a great video to watch. Also, on a side note, I'm working on this little guy here. Anybody knows what this RC car used to be? It used to have a V8 engine coming out of the hood. I 3D printed a panel that came out just like, I mean, it's like perfect in there. So this is going to be a really neat little tiny side project here. But we have full independent suspension Hornet coming out soon. We have new Blackfoot rear suspension coming out. We've got, God, I've really got to go outside at some point. Anyway, I'm going to go drive this and have an awesome time. Please subscribe, like the video if you liked it, and check out my Facebook as well as my Instagram. It's Ampro Engineering for both of them. Please check out the band Blue Pinto. They provide all the songs for my videos, and a link to their Facebook page is at the end of this video. Thank you again. I really hope you enjoyed it, and we will see you next time.